In recent years, the question of whether extraterrestrial life exists has shifted from the realm of science fiction to a more serious scientific inquiry. While UFO sightings have been reported for decades, the modern approach to tracking these unidentified flying objects has undergone a drastic transformation thanks to technological advancements. Today, scientists are leveraging satellites in space to track and monitor UFOs in real time, bringing a new level of precision to the search for alien life and challenging our understanding of the universe. Satellites have always been at the forefront of scientific exploration, providing insights into Earth's weather patterns, climate changes, and even distant planets in our solar system. But now, scientists are using satellites to monitor what's happening right above our heads. With advanced sensors and high-resolution imaging technologies, these space-based tools can capture anomalous movements in our atmosphere, movements that could very well be linked to UFOs. The first step in this process begins with the detection of something unusual. Satellites equipped with infrared sensors are particularly adept at spotting heat signatures. UFOs, particularly those exhibiting unconventional flight patterns or speeds, can generate heat due to the friction between the object and the atmosphere. This heat signature can be detected from space, offering scientists a first glimpse of something that could potentially be an unidentified object. One of the most prominent examples of this technology in action comes from the work of a group of researchers from the National Oceanic and Atmospheric Administration, NOAA. Their satellites, primarily used for weather forecasting and environmental monitoring, have also picked up anomalous signals that appear to come from objects moving at high speeds in Earth's atmosphere. These signals, often too brief to be captured by traditional radar systems, have led to more detailed investigations. As part of these investigations, scientists are using multiple satellite systems to cross-reference data. For example, the European Space Agency's Sentinel satellites, which are designed to monitor the Earth's surface, have been used to detect changes in the atmosphere that might indicate the presence of an object with unconventional flight characteristics. When cross-referenced with other data from satellites in low Earth orbit, scientists can piece together a more complete picture of what's happening in real time. The real power of these satellites lies in their ability to track these objects over long distances. Unlike ground-based radar, which has limited range and can be affected by weather conditions or geographical obstacles, satellites can monitor vast swaths of the planet's surface, providing a more consistent and comprehensive view. This allows scientists to detect anomalies in places where human observers may not be able to spot them, such as remote parts of the ocean or deep in the atmosphere where UFOs might be operating. One of the key breakthroughs in the ability to track UFOs in real time is the development of advanced machine learning algorithms. These algorithms are capable of analyzing the vast amounts of data gathered by satellites and identifying patterns that might be indicative of an unidentified flying object. Rather than relying on human analysts to manually sift through enormous amounts of data, machine learning can automatically flag potential UFOs for further examination. These algorithms can also filter out mundane objects like satellites, debris, or weather phenomena, ensuring that only the most intriguing data points are investigated. To aid in this process, some satellite systems are equipped with optical and radar imaging systems that can provide highly detailed visual data. For instance, synthetic aperture radar, SAR, on certain satellites can create images of the Earth's surface or atmosphere with remarkable clarity. By capturing radar reflections from objects moving through the sky, these systems can create precise images of objects that are difficult to spot with traditional optical telescopes. With the right equipment, scientists can even track objects that are cloaked or otherwise difficult to see with the naked eye. Another interesting development is the use of commercial satellite networks. In recent years, private companies such as SpaceX and Planet Labs have launched large constellations of small satellites into space. These satellites, although initially designed for purposes like Earth observation, communications, and data collection, can also be repurposed to assist in the tracking of UFOs. With thousands of satellites now in orbit, the collective data they generate can be used to monitor the skies more comprehensively than ever before. In fact, some researchers are already beginning to analyze data from these commercial satellites, looking for patterns that could suggest UFO activity. But it's not just satellites that are improving the accuracy of UFO tracking. As technology continues to evolve, it's likely that we will learn even more about these mysterious objects in real time, perhaps even discovering the answer to one of humanity's most enduring questions: are we alone in the universe?